Hey Math 8. Today we are doing surface area of prisms and of pyramids. I know we just finished up with volumes, so now we are going into surface area. All right, so yeah, let's just go ahead and get into it. So when we look at surface area, you're going to notice we still have formulas specifically for a rectangular prism. We've got formulas like this one, or we've got this one where we have B is the area of the base, P is the perimeter, and H is the height. That said, there are other ways that we can do this, or another way, I guess. And the way that I'm talking about is just using nets. Okay, so if we look really quickly at an example of a rectangular prism like this, okay, and this isn't going to be perfect by any means, but if we've got a rectangular prism like this, I can go ahead and imagine that this is all taken apart and just find the area of each portion. Okay, so for a rectangular prism, that would be the front, okay, and then the top would look something like this. All right, and no, I'm aware that these are not going to look perfect. That's okay. And then we have the back. Okay, the back and the front should be about the same size, so that one's really not very good. It's at least a little bit better. And then the bottom. Okay, for some reason this just connected those two. There we go. And then we've also got the two sides, which should line up like this. Okay, so we can picture it this way. It's not required for you to understand that that's how it works, right? You can also just zoom in on it like I'm doing here and just kind of write something or keep track of what you found, right? So I like to do front and then back, and we have the top, and then we have the bottom of it. I like to do a lowercase b for the bottom, and then we have the right side and the left side, right? So in order to do these, we can just look at which ones we've already done, which ones we've already found the area of, and then add those all together. All right, that's going to be the same thing. Okay, so you can do it with the formulas, and for some of you it might be easier to use this formula and just plug in the numbers. But for those of you who don't want to remember the formulas or remember which formulas go where, this is perfectly fine as well if you just find the area of each part and then call it good at that. All right, another way that I've seen done is, you can just write it off to the side, right? So if we've got, we find the top, and that's whatever, and then next I'm going to do the bottom. Well, I know the bottom and the top have to be the same, so it's just going to be the same thing as the top. And I've got left. I'm going to try the left one, find it, and afterwards I know the right has to be the same as the left for a rectangular prism. So I'm going to find that one. And then we've got front and back. Okay. And so sometimes it's helpful if we just list all these out and then go ahead and draw from there what they all are. Or sorry, I guess solve from there what each one is and then write it in. So yeah, there's multiple ways you can go about finding surface area. And these are just a few that I have seen. Just make sure you find the area of each side. Okay, so this one, this one, this one, this one, this one, and this one. If we look at the net, just find the area of each side and then add them all together. Right? That's what the surface area really is. Okay, so let's go ahead and look at an example for a rectangular prism. Now I'm going to erase all mine that I have here, and we're just going to go ahead and look at what the book's got because they've got better pictures than I can draw. if we're being honest. Okay, so yeah, we'll look at example 1 here. We've got this rectangular prism with 13 by 7 by 9. Those are our dimensions. Okay, so we can use the formula that I've got up here highlighted. I prefer that over the one that they've got here in the book, but if you like the one in the book, again, they're both going to work fine. But I will do this one over here where we've got SA equals 2 times the base plus the perimeter times the height. All right. So just as a reminder, the capital B stands for the area of the base. Okay, so not just the 9, but the area of the entire base. So that 9 by 7 bottom square there. All right, or bottom rectangle is going to be our base for this problem. All right, so let's go ahead and jump into it. So once we have the formula, if we choose to use the formula, we are just going to go ahead and plug in. All right, so we have surface area equals 2 times B. Well, B is the area of the base. In order to find the area of the base, we're just looking at the area of a rectangle. Remember, that is length times width. Okay, and when I do length times width, that's going to be 7 times 9, which is going to give us 63. Okay, so we have 2 times 63 plus, and then P, so this, it is important to note, is not just perimeter, right, but perimeter of the base. All right, that can be very confusing. Just find the perimeter of the base. Do not try to find the perimeter of this entire thing with all of these sides, you know, because that's going to be way too much. You don't want that. Okay, so don't find all of those sides. That's going to be insane. That'll be way higher than what you're looking for. All right, so just the perimeter of the base, that's going to be our 9 and our 7. And remember, this side back here is also 9, and this side over here is also 7. All right, so our perimeter is going to be 9 times 2, which is 18. And then 7 times 2, which is 14. We can add those together, and that'll give us 32. So we're going to have 32 for P, and then the height is our 13. All right, after we've done this, we can go ahead and plug those into our calculator. 2 times 63 should give us 126. And 32 times 13, I am not sure what that is without a calculator. So when I type that in, I get 416. All right, and then I just got to add those together. And that's going to give me 542. All right, now for surface area, it is inches, but even though we have a three-dimensional figure, we're going to have inches squared. All right, now the reason it's inches squared is because we are finding surface area. All right, area is just a two-dimensional measurement, right? So you wouldn't find, or I guess you wouldn't find a three-dimensional area, right? That would be the volume. Okay, area is just for 2 dimensions, so that is why we have inches squared or square inches, all right, for our surface area. Okay, if you choose to do this the other way, right, where we don't use this, if you wanted to copy this down, go ahead and pause the video and do it now, because I'm going to go ahead and move on. All right, so if you wanted to do this the other way, just a reminder, I would find the front, and then I would find the bottom, and then the top, and then the right side, the left side, and the back. All right, and then once you've done that, you are good to go. You've got everything found, right? So you would want times 7, okay, that would be both the bottom and the top. 13 times 7 is going to be the left and the right, and then 13 times 9 is going to be the front and the back. All right, now you'll also notice when I did it this way, another way you can keep track is I have everything underlined twice, right? So I know that I need to do each thing times the other two. So each one has to multiply by two different things. 13 has to multiply by 7. 13 has to multiply by 9. Okay, 7 has to multiply by 9, and it's already multiplied by 13, so we're good. And then the 9 has now been multiplied by both of them. All right, so that's just another way that you could try to keep track of what you've already done. All right, go ahead and try out Got It Problem A and Got It Problem B. All right, now you'll notice Got It Problem B is also a cube, okay, because all three of these are the same. So there might be something you notice if you haven't noticed it already while you're doing this problem about cubes and their surface area. So go ahead and do that, pause the video, and then we'll come back after that. All right, so now we'll move on to the surface area of triangular prisms. Okay, so we'll just go ahead and look at, well, I think this is a good example, right? So we have this triangular prism up here. Okay, it gives us the dimensions, right? So we've got 14 feet is this length right here. We got 4 feet is the base length, that bottom length. And then 3.6 is this length here. And we also know, since it's an equilateral triangle, that's going to be the length for this side and this side, as well as this side and this side as well. Sorry, I said that wrong. It'll be the length for this side. It will not be the length for the bottom. That's 4 inches, which we see right here. Okay, and then 14 is also going to be this side and this side. All right. And then, yeah, so they went ahead and took sort of what you could call a net. It's a little bit different because they broke everything up. But these are all the sides of this triangular prism. Okay, so you'll notice there's 5 sides. We got 2 triangles, the front triangle and the back triangle. And then we also have the 3 sides. We've got the top right, and if we erase it, we've got the top left here. And then we've also got the bottom right here. Okay. All right, so we'll go ahead and get going on finding the surface area. So this is one that they suggest you do like this sort of net idea like we did on the last one, or like I gave you the option to do on the rectangular prisms. So you want to start by finding these areas. Now it gives you that this is 3 inches, which is really, really nice for this, because then we can just find the area of the triangle. All right, so the area of a triangle is going to be 1/2 base times height. That's a lowercase b. Okay, so then we have 1/2 times 3 times 4. All right, that'll give us 1/2 times 12, which is just 6. Okay, and then you'll notice we have 2 triangles. So we can go ahead and multiply that by 2. And there's our area for the triangles. We got 12 inches. Okay, then we can find 14 times 3.6 for the area of the rectangles. All right, and there are 3 of those, so we're going to multiply that by 3 as well. All right, so we've got 14 times 3.6. I put it in my calculator. I get 50.4. All right, with that 50.4, I'm going to multiply by 3 because there are 3 of those rectangles, and I'm going to get 151.2. All right, and now I'm going to add these 2 measurements together. That's going to give me 163.2 inches squared. And these should have been squared as well. All right, so that is our final answer for this one. I know it wasn't a numbered example, but yeah, that's how we would find that. And yeah, that's it for the surface area of a triangular prism. Okay, so I want you to go ahead and try out Got It Problem D right here on your screen. And then we will go ahead and move on from there. All right, so the last shapes that we are looking at here are our pyramids. Okay, now this is a good formula to know, but again, you don't have to do it this way. You could look at the net of a square pyramid in order to find your surface areas. If you want to use the formulas though, the formula is going to be surface area equals the base plus 1/2 the perimeter times L, and L is slant height. Okay, so slant height is going to be, if you look at the net, it's going to be this dotted line right here. All right. So yeah, we will go ahead and look at an example or two of those. So if we just go down right here. All right, let's start with example 1, where we have this shape right here. Okay. All right, so I am once again just going to show how we would use the formula. But again, if you would prefer the nets, totally up to you. You do not have to use the formula if you prefer the nets. All right, so for this formula, we have surface area equals base plus 1/2 the perimeter of the base times the slant height. Now, also for pyramids, I didn't mention this yet, but you'll notice there are square pyramids like this where the base is a square. And you've also got triangular pyramids like this one where the base is going to be a triangle. All right. The formula works for either of those two, which is pretty nice. All right. It works for any of your pyramids. Okay. So if we look at this one, we're going to go ahead and just plug in. So we have SA, or surface area, equals the base. That's the area of the base. So we have 4 times 4, which is 16. All right, I got that right here, 4 times 4. And then we have 1/2 times the perimeter of the base. Okay, well, both sides are 4, as we can see. So that means these are going to be 4 as well. All right, so we have 16 for the perimeter as well. It would just so happen for this one. And then the slant height is our 9 right here. All right. So I can go ahead and put that into my calculator or just solve it as I've got it, which I think I might do. So I have 1/2 times 16, which is just 8, and then times 9. So then surface area will be 16 plus 72, which is going to give us 88. And that'll be inches squared again. All right. And that's it for the surface area of a pyramid. Okay. So regardless of what pyramid you have, whether it's a square pyramid, triangular pyramid, maybe we'll have an octagonal pyramid, right? Any of those, this formula is going to work. Okay. All right. That is it for this video, other than this last got it problem. Okay. So I want you to go ahead and do got it problem B. You're just finding the total surface area of the pyramid that they show you right there. And once you have done that, you are done with this video. I know it's been a long one. It's over 18 minutes, so sorry about that. But go ahead and get it done, and then that'll be it. So I will see you guys back in class.